slanted line. How many of you can see that right? It takes a little imagination. Here's what it looks like. Now you see it, right? We're going to use this concept to find the distance between those 2 points. Hey, as soon as I say right triangle, what concept comes to your mind? Pythagorean theorem. Ladies and gentlemen, that ought to be universal. Every time you see a right triangle presented, or something that can be interpreted through a right triangle, you ought to be thinking, oh, Pythagoras, all right? And the summation of the Pythagorean theorem is, how do you see it? How does it go? A squared plus b squared equals c squared. Does it matter which of the 2 sides is A or B?
No.
No. Does it matter which side is C? Absolutely. Tell me about C.
It's
the hypotenuse. What does that mean?
The longest side.
Longest side. It's also the side that's opposite the right angle. So we know this guy right here is the hypotenuse. Hey, the distance we're looking for is the hypotenuse. Well, check it out, ladies and gentlemen. The other 2 distances are vertical and horizontal distances. I can count units. And so that's exactly what I'll do. 1, 2, 3, 4, 5, 6. That's 8 units. And 1, 2, 3, 4. That's 6 units. Can I now find D? Yes. Pythagoras says I can. And he's a wise old buzzard, so I'm going to try it. Let's see, 8 squared plus 6 squared equals the distance squared. That's 64 plus 36 equals distance squared. 100 is the distance squared. D must be. Now, how come you didn't say, oh, plus or minus 10? Distance what? Distance is not negative. Absolutely. Remember that concept? We talked about it relative to absolute value. Distance is not negative. So we will choose, thank you very much, the positive square root of 100. Hey, how about that? So if I'm given 2 points, all I have to do is take a piece of graph paper, draw 2 points, connect them, create the new invisible right triangle, count the units, submit the Pythagorean theorem, solve the Pythagorean theorem, choose a positive square. That's a lot of stuff to do. Maybe there's an easier way. In fact, there is. Watch this. Let's say we did not know what this particular point was. In fact, let's just use some general points instead of these specific points. Let's just use some general points. How do I refer to a general point on the grid if I don't know what it is? Okay. How am I going to talk about this point? I don't know what those numbers are. I'm not even going to try to count. It's just some general point. How do I? X, Y. Thank you. Yes, it's just X, Y. It's just X, Y. That's how you talk about a general point. You know, I don't know specifics about it. Hey, here's another general point. How are we going to talk about this general point? The X, Y. Wait a minute. Those look strangely similar. In fact, they look identical. How can I tell one from the other? Thank you. Subscripts. Subscripts are going to allow us to call this guy X1, Y1, this guy X2, Y2, simply meaning the first unknown point and the second unknown point. Notice those are not exponents. Did you notice that? They're just designations between the first point and the second point. And we're still looking for this distance right here. Right? Still looking for that distance. And I got my concept here. The invisible right triangle that becomes wonderfully visible. All right, here's something I want you to notice about our original triangle. This distance is not just 8. Notice that this is also the difference between my two x values. This is x minus x. This is basically x2 minus x1. And notice that this distance 6 is not just found by counting units, it's also the difference between my two y values. It's y2 minus y1. What do you know? So in general, anytime I have 2 points, this horizontal distance is going to be the difference between your two x's. It's going to be x2 minus x1. That's how long it is. The length of this guy is going to be the difference between my two y's. It's y2 minus y1. Now, as I say that, I have the two sides again of my right triangle. There's one side. There's the other side. I'm looking for the third side. So let's fill into old Pythagoras' theorem. A here squared plus b squared equals c squared, which happens to be d. And there you have, ladies and gentlemen, a formula for the distance squared. But I'm not really interested in a formula for the distance squared. I'm interested in a formula for the distance. So what am I going to have to do? Square root of both sides. So take the square root of d squared and I get d. And if I take the square root of all this mess, I get the square root of all that mess.
Thank you.
And notice, ladies and gentlemen, taking the square root of a sum of things squared is not their individual square roots. This is not the same as x2 minus x1 plus y2 minus y1. Because this says add first, then take your square root. Remember, a radical is in essence a parenthesis. It is in essence a grouping symbol. So it says do everything in here first, then take your square root. This, ladies and gentlemen, is solid gold material for your 3x5. You're going to want that on your 3x5 card if you don't have it memorized. Yes, ma'am?
Can you not just cancel the square root of the squares because the index and power is the same?
You can't. Now, I'll give you an example in just a second, all right? In fact, let's use the last guy we did, this guy, to now find the distance in an easier way. Hey, instead of using graph paper, plotting the points, drawing the line, do the triangle, counting the units, do the Pythagorean theorem, right? I can simply use d equals square root of x2 minus x1 squared, y2 minus y1 squared. So all I got to do, and I highly suggest that you do it, is label one of these guys x1, y1, and label the other one x2, y2. And I suggest you do it, actually physically put it on paper, because you're juggling things and something's going to get mixed up and dropped and tragedy will occur. All right. So the distance is the square root of, let's see, x2 minus x1, that's 11 minus 3. And y2 minus y1, that's 11 minus 5 squared. So I get the square root of, that's 8 squared and 6 squared. Get the square root of 64 plus 36. Square root of 100. I get t. So without even needing any graph paper, just simply labeling one of the points x1 and y1, the other one x2, y2.